For decades, the name Toyota has been a global synonym for reliability. It's the brand you buy when your primary goal is to get from point A to point B every single day for hundreds of thousands of miles, with nothing more than routine maintenance. Toyota built an empire on the promise of sensible engineering, bulletproof engines, and a near-fanatical devotion to quality control. A Toyota wasn't just a car, it was a pact, an assurance that it would never let you down. This reputation is the company's crown jewel, polished by millions of satisfied owners and legendary tales of trucks and sedans that simply refuse to die. But in the relentless march of progress, even giants can stumble. The modern automotive market demands more than just reliability. It demands cutting-edge technology, unparalleled fuel efficiency, and a list of comfort features as long as your arm. To compete, Toyota has been forced to adopt new, complex systems and technologies, some of which stand in stark opposition to the brand's core philosophy of simple, durable engineering. The result is a new generation of vehicles that, while still excellent in many ways, now harbor features that can introduce shocking fragility and astronomical repair costs, betraying the very legacy they trade on. Before we move ahead, make sure to like the video and subscribe to the channel. Chapter 1. The New Heart. Murmur. Complicating the bulletproof engine. The cornerstone of Toyota's reputation was forged in the simple, overbuilt engines of the past. The cast iron blocks and straightforward designs that could withstand incredible neglect and still keep running. The modern engine bay, however, tells a different story. In the race to meet stringent emissions and fuel economy standards, Toyota has introduced complexity that chips away at this legendary fortitude. The double-edged sword of D4S injection. One of Toyota's most celebrated engine technologies is the D4S fuel injection system, which cleverly combines both direct injection, DI, and traditional port injection. On the surface, this is a brilliant solution to a major problem plaguing other automakers. Direct injection, which sprays fuel directly into the cylinder, is highly efficient but causes severe carbon buildup on the intake valves since fuel no longer washes them clean. This carbon buildup eventually chokes the engine, reducing power and efficiency, and requires expensive cleaning services. Toyota's D4S system solves this by adding a set of secondary port injectors that spray fuel onto the valves under certain conditions, effectively keeping them clean. It's a fantastic piece of engineering that works. However, it achieves this reliability by doubling the complexity. You now have two separate fuel systems, twice the number of injectors, two fuel pumps, a low-pressure pump in the tank, and a high-pressure mechanical pump on the engine, and a sophisticated computer system to manage it all. While Toyota's injectors are famously reliable, you have now doubled the potential points of failure. The high-pressure fuel pump is a new mechanical component driven by the camshaft, introducing a new wear item that simply didn't exist on older engines. Diagnosing issues within this dual system is also far more complex and expensive for mechanics. You are paying for and maintaining 8, 12, or even 16 injectors instead of 4, 6, or 8. It's a clever solution, but it fundamentally violates the old Toyota ethos of simple is better. The most reliable system will always be the one with the fewest moving parts, and D4S, for all its benefits, is a step in the wrong direction from a pure, long-term durability standpoint. The turbocharging temptation. For decades, if you wanted a powerful Toyota truck or SUV, you got a big, lazy, naturally aspirated V8. The 5.7-liter I-Force V8 in the old Tundra and Sequoia is a legend. Thirsty, yes, but also capable of easily lasting 500,000 miles or more. Today, that engine is gone, replaced by the iForce Max, a twin turbocharged V6 hybrid powertrain. This new engine produces more power and torque and delivers better fuel economy, which looks fantastic on paper. But it achieves this by putting a smaller engine under immense stress. Turbochargers operate in an extreme environment, spinning at hundreds of thousands of RPM while being subjected to scorching exhaust gases. They add a massive amount of heat and pressure to the system, along with a web of intercoolers, plumbing, waste gates, and oil lines, all of which are potential failure points. Instead of a simple, robust V8, you now have an engine with two turbos, a complex hybrid system with an electric motor generator sandwiched between the engine and transmission, and a high-voltage battery pack. That's three incredibly complex and expensive systems replacing one simple one. While Toyota's engineering is top-notch, there is no escaping the fact that this new powertrain has exponentially more potential points of failure than the V8 it replaced. For the owner planning to keep their Tundra for 20 years, this added complexity is a terrifying proposition. The long-term reliability of these high-strung turbo engines simply cannot match the proven, unkillable nature of their naturally aspirated predecessors. Chapter 2. The drivetrain's weakest link, chasing efficiency at the cost of strength. The transmission is just as critical as the engine for long-term reliability. Toyota's traditional automatic transmissions are renowned for their smooth operation and incredible longevity. However, the push for ever higher MPG numbers has led to the widespread adoption of a technology that is fundamentally at odds with the concept of long-term durability. The CVT conundrum. The continuously variable transmission, CVT, is now standard in many of Toyota's most popular vehicles, including the Corolla, RAV4, and Camry. Unlike a traditional automatic, which uses a set of fixed gears, a CVT uses a pair of variable width pulleys connected by a steel belt. By constantly changing the diameter of these pulleys, the transmission can keep the engine at its absolute most efficient RPM for any given speed. This results in excellent fuel economy and incredibly smooth, shift-free acceleration. The problem is the inherent fragility of the design. The entire torque of the engine is transferred through a relatively small steel belt, which is under immense tension and friction. Over time, this belt and the pulleys can wear out. Unlike a traditional automatic that might give you warning signs like slipping or hard shifts, a CVT failure can often be sudden and catastrophic. When the belt goes, you're not going anywhere. Repairing a CVT is also a specialized and expensive job. Most shops won't even attempt it. A replacement is the only option, and it can easily cost upwards of $5,000 to $7,000. While Toyota's CVTs are considered the best in the business and often include a physical launch gear to reduce wear from a standing start, they do not share the same million-mile reputation as the brand's old 4-speed and 6-speed automatics. For drivers who prioritize ultimate long-term, trouble-free ownership, a vehicle with a traditional geared automatic transmission is a far safer investment. The marginal fuel savings of the CVT are simply not worth the risk of a single, devastating repair bill. The illusion of all-wheel drive. Many Toyota sedans and crossovers are now offered with all-wheel drive, AWD, providing extra traction and security in inclement weather. This sounds like a purely beneficial feature. However, it adds a significant layer of complexity and maintenance cost to the vehicle for a benefit that many drivers, particularly those in warmer climates, will never truly need. An AWD system includes a center coupling or differential, a rear differential, a drive shaft, and extra CV axles. These are all components that do not exist on a standard front-wheel drive FWD model. Each of these parts contains fluid that needs to be serviced periodically, adding to your maintenance bills. More importantly, they are all potential failure points. The seals on the differentials can leak, the U-joints on the drive shaft can wear out, and the electronic clutch packs in the center coupling can fail. A repair to the AWD system can be expensive, easily running into the thousands. For someone living in a region with minimal snow or ice, they are paying a penalty in terms of purchase price, reduced fuel economy due to drivetrain loss and extra weight, higher maintenance costs, and increased long-term reliability risk, all for a feature they rarely, if ever, use. Unless you genuinely need the extra traction, the simpler, more efficient, and more reliable FWD version is the smarter choice. Chapter 3: The Electronic Spiderweb, When Safety Creates Fragility. Modern cars are rolling supercomputers, and Toyota is at the forefront with its Toyota Safety Sense TSS suite of driver assistance features. These systems, which include pre-collision warning, adaptive cruise control, and lane-keeping assist, have undoubtedly made driving safer. But they have also wrapped the vehicle in an invisible, fragile, and incredibly expensive electronic spiderweb: the $2,000 windshield replacement. One of the most common and unavoidable repairs on any vehicle is replacing a cracked windshield. What used to be a simple $300 to $400 job has now become a multi-thousand-dollar ordeal on many new Toyotas. The reason is that the forward-facing camera for the TSS system is mounted to the windshield. When the windshield is replaced, this camera must be removed and reinstalled on the new glass, and then the entire system must be recalibrated by a dealer or a specialized shop with the proper equipment. This calibration process is precise and time-consuming, and if it's not done perfectly, none of the advanced safety features will work correctly. The calibration alone can cost hundreds of dollars on top of the already more expensive specialized windshield. A simple rock chip can now lead to a bill of $1,500 or more, a cost that many insurance policies may not fully cover depending on your deductible. It's a staggering price to pay for a common repair. The peril of bumper sensors. Similarly, the radar sensor for the adaptive cruise control and pre-collision system is typically located in the front grille or lower bumper area. This places a highly sensitive and expensive piece of electronic equipment in the most vulnerable part of the car. A minor parking lot bump, a fender bender, or even hitting a piece of road debris can damage this sensor or knock it out of alignment. Like the camera, this radar sensor requires precise calibration. A replacement and recalibration can cost thousands of dollars. Suddenly, a minor cosmetic bumper repair turns into a major electronic systems overhaul. This extreme fragility turns everyday driving incidents into potential financial disasters. While the safety benefits are real, owners must be aware that these systems have dramatically increased the cost and complexity of even the most minor collision repairs, impacting both insurance rates and out-of-pocket expenses. They are, in essence, a hidden tax on vehicle ownership. Before we move ahead, make sure to like the video and subscribe to the channel. Chapter 4: Useless upgrades that sabotage your car. Beyond the major mechanical and electronic systems, modern Toyotas are filled with smaller features and design choices that, while seemingly harmless or even luxurious, can lead to significant problems and expenses down the road. The leaky nightmare of the panoramic sunroof. A panoramic sunroof can make a car's interior feel open, airy, and luxurious. But in terms of long-term reliability, it is one of the single worst features you can add to a vehicle. A massive sheet of glass on a flexible metal vehicle body is a recipe for trouble. The primary issue is water leaks. The sunroof assembly has a complex system of drains and gutters designed to channel water away. These tiny drain tubes can easily get clogged with leaves, pollen, and other debris. When they do, water backs up and spills directly into the car's interior, potentially ruining the headliner, soaking the carpets, and, worst of all, damaging sensitive electronic modules located under the seats or in the dashboard. Chasing down a sunroof leak can be a maddening and expensive process. Furthermore, the motors and mechanical tracks that operate the sunroof are another common failure point. A failed motor or a broken track can leave the sunroof stuck open, exposed to the elements, and can cost over $1,000 to repair. For all its aesthetic appeal, a panoramic sunroof adds immense risk for water damage and mechanical failure. The most reliable roof is a solid sheet of steel. The rodent attraction of soy-based wiring, in a well-intentioned effort to be more environmentally friendly, Toyota, like many other automakers, began using soy-based materials for the insulation on electrical wiring harnesses. The unintended consequence was catastrophic. This new wiring was incredibly attractive to rodents. Mice, rats, and squirrels found the insulation to be a delicious food source, leading to countless cases of critters nesting in engine bays and chewing through critical wiring. The damage can be devastating, causing everything from random check engine lights to a car that won't start at all. Repairing a chewed-up wiring harness is an electrical nightmare. It's not a simple part replacement. A mechanic must painstakingly trace and repair dozens of individual wires. It is extremely labor-intensive, and costs can easily soar into the thousands of dollars. While Toyota has faced lawsuits over this issue and has likely reformulated its materials, it remains a cautionary tale of how a seemingly positive, eco-friendly feature can have disastrous real-world consequences for vehicle owners. Conclusion: upholding the true Toyota legacy. To be clear, Toyota still makes fantastic, reliable vehicles, but the era of universal, unconditional invincibility is over. The pressure to innovate, to be more efficient, and to be more luxurious has forced the company to adopt complex technologies that inherently compromise the simple, durable nature that defined its legacy. The wisest consumer is the one who understands this new reality. The path to a truly long-lasting, trouble-free Toyota is paved with careful choices. It means prioritizing the proven over the novel. It means choosing the naturally aspirated engine over the turbo, the traditional automatic over the CVT, and the solid roof over the panoramic sunroof. It means understanding that the simplest version of the car is often the best one. The true Toyota legacy isn't found in the giant touchscreens or the complex driver aids. It's found in the promise of a car that starts every morning and gets you home every night without drama. By being a discerning buyer and avoiding these useless reliability-sapping features, you can still own a vehicle that honors that original promise and upholds the legend for decades to come. So what are your thoughts? Make sure to like the video and subscribe to the channel.